A pleasant day to everyone. Today we're going to discuss Module 4 of subject CE 4 to 11, Transportation Engineering. So, in this lecture, we're going to discuss traffic demand forecasting. In estimating or forecasting the travel demand, we have to first identify or learn the definition of the following terms. We have trip, which is a one-way person movement by a mechanized mode of transportation having two trip ends, that is the origin and destination. So there are two types of trips. We have the home-based trips, which is wherein one end of the trip is the home of the trip maker, and the other one is the non-home-based trip, which it's a trip wherein neither end of the trips are the home of the trip maker. So an example of a home-based trip is simply you coming from your home going to the school and school to home. While for non-home based trips, that's an example of that would be coming from the school going to SM to school, or any other place aside from your home. The trip ends is simply the production or generation or attraction in our travels. Trip production is a home end is the home end of a home-based trip, and it's the origin end of a non-home-based trip. So meaning, a trip production is simply the location where the trip has started. And then we have your trip attraction, which is the non-home end of a home-based trip, and the destination is the end of the non-home end for a non-home based trip. So trip attractions, that would simply be your final location or final destination of your travel. So the total productions, take note that the total productions must be equal to the total attractions. So let's say there are 5 trips coming from the origin, then there should be 5 trip ends also as well in the destination or the end point of the travel. So for travel demand forecasting, this now allows traffic engineers to predict or estimate the volume of traffic that will be used given a transportation element in the future. This is applied for existing highways or potential light rail route. So we have one of the models that we apply for travel demand forecasting, which is the 4-step forecasting model. So from the name itself, it has 4 steps to follow, and this is the most commonly and widely used model for forecasting. It is necessary that the socioeconomic indicators would affect your travel demand forecast or estimation. The socioeconomic indicators now would include the population, the income or the economy of the location in which we are forecasting, and then the number of vehicles in that location, and other factors that would affect social and economic values of the area. So for the 4-step forecasting model, there are basically 4 steps, or what we call the submodels. So the first one is what we call the trip generation and attraction, which estimates the total number and types of trips originating and terminating in the areas or zones of the trip. The second submodel, is the trip distribution, which computes the number of trips between one zone and all other. The third submodel is the modal split, which is the percentage of travel of particular transportation mode. So meaning what kind of transportation you are going to use in order to arrive from your origin to your destination. And then we have your traffic assignment, which is concerned with the selection of route or path between origin and destinations in a transportation network. For the first submodel of the four-step forecasting, the trip generation and attraction, we have to use what we call the origin destination table or the OD matrix. This is used for a systematic analysis and an easier presentation of the trip generations and attractions. This would simply show us the trips from one zone to another zone within a given study area. So for the OD matrix, the following terms will be used. O sub I is the trip generated from zone I, or the originating trip of zone I. So this is the trip generation. D sub j is the trips attracted to zone J, or the destinations, trip attraction. And then we have T is the trip production, which is defined by either the trip generation or the trip attraction for zones I and J. So the area of study for an origin destination table and trip generation and attraction will be divided into zones. So for our zone types, we have what we call the internal zones, which will be the zones within the study area, which is defined by political and or administrative boundaries. And this will be corresponding to a barangay, a town or city, which is based on the scope of the study. And then we have what we call the external zones, which are the zones that is outside the study area, which may greatly affect the trip patterns. So an example of internal zones, let's say Baguio City. So internal zone will be the different barangays within Baguio. So that will be, let's say, Insao, Aurora Hill, Francoville, Fort del Pilar, Kias, and so on. External zones with respect to Baguio will be La Trinidad, as La Trinidad could greatly affect the trip patterns of Baguio. Likewise, if our study area is La Trinidad, then Baguio is an external zone since the trips from Baguio would greatly affect the trip pattern of La Trinidad. Another example for internal zones is if our study area is, let's say, the Cordillera region, then the internal zones will be the different regions in CAR. So that will be Benguet, Ifugao, Mountain Province, and the rest. While external zones for the Cordillera Administrative Region would be those zones that would affect the traffic or the trip patterns in Cordillera. That would be Ilocos, so La Union, Pangasinan. So those are external zones. If an external zone will not be affecting will not have a big effect on the trip patterns of the study area, then we will have to neglect the external zone in our study. So we will not include it in the zones of your origin destination table. Okay. So this is now an example of an OD matrix. As you can see, we have here the origin, you have your destination, and the sum of all the origins will be O sub 1. So from origin 1 going to destination 1, 2, or zone 1, zone 2, zone 3, until zone N. And the trips here, or the trip production, will simply be the sum of all your origins or the sum of all your destinations. Take note, O sub 1 is the number of trips from zone 1. So that will be D1 plus D2 plus D3 plus D4 until N. And then we have D2 will be the number of trips going to zone 2. So that will be O1 plus 2, origin 3 until ON. So the sum of this one. We have here Tij is the number of trips from zone I to J. So from zone I going to J, the total value here will be those trips coming from I to J, and T is your trip production. Okay? So to understand origin destination table, let us have an example. So given the table is an OD matrix for area of study composed of zones 1, 2, 3, and 4. So we have here your OD matrix. So you have the origin from zone 1, zone 2, zone 3, zone 4. Destination is 1, 2, 3, 4. So this table would simply mean that from zone 1, there are 11 who are going to zone 2. From zone 1, there are 23 who are going to zone 3. From zone 1 going to zone 4, we have 88 trips. Okay? So the total trips coming from zone 1 will be 122, or the sum of these values. Then if we're going to look here, those going to zone 2 from zone 1 is 11. Going to zone 2 from zone 3 is 2. And going to zone 2 from zone 4 is 18. Adding up these values, we have 31, which would simply mean that there are 31 trips going to zone 2. So for this problem, we are now going to determine the following values. So we have the trip productions for zone 1, and this will be computed simply. So production, ibig sabihin, how many trips are coming from zone 1. So that will now be 122. Next, trip productions of zone 3. So we have zone 3 will be 99. Then we have the trip attractions of zone 2, which is 31. Trip attractions of zone 4, meaning how many trips are attracted or going to zone 4. That is equal to 119. And then for letter E, the trips from zone 2 to zone 4. So meaning how many trips are present from zone 2, so from the origin 2, going to zone 4. So that is now equal to 27. Then next, we have the trips from zone 4 to 2. So going from zone 4 and going from zone 4 and going to zone 2, we have 18. And then we have the trips from zone 3 to zone 1 is 93. That's from 3, zone 3, going to 1, 93. And then we have the total trip production for the area study will simply be equal now to the summation of the origins or the summation of the destinations, which is now equal to 309. Okay, so there are no values for the diagonal since we assume here, or the recorded values would mean, so if there are no values here, it would simply mean that there is no interzone travel. So meaning no travel between and from 1 to 1, 2, 2, and 3 zone, within 3, 3, and within zone 4. So under trip generation and attraction, aside from using your OD matrix, we also follow what we call the growth factor method. So in here, the number of trips are assumed to be influenced by several variables, such as our socioeconomic factors, like your population, income, and vehicle ownership, or number of vehicles. So the future values of variables are estimated statistically, where the future trips may be based on the growth rates of variables. So our general equation now for the growth factor method will be T sub I prime is equal to T sub I times F sub I, wherein F sub I is your growth factor, which is the future to present ratio, which is computed as P prime over P times V prime over V times I prime over I, wherein all the prime values are your future values and those without prime will be our present values. So to understand growth factor method, let us have an example. So we have the trips originating from zone 1, 2, and 3 of a study area are 78, 92, and 82. 78, 92, 82, respectively. Those terminating at zones 1, 2, and 3 are 82, 96, and 74. So if the growth factor is given as 1.2 and the base year trip matrix is given, this is the base year matrix, find now the expected origin constrained growth trip table. So what we are going to do here is first to multiply the growth factor of 1.2 to each of the individual interzonal trips. So multiplying now 1.2 for each of our trips, we get now 20 times 1.2 is equal to 24. Next, we have 30 times 1.2 is 36. 28 now increases to 33.6. Next, we have 36 times 1.2 will give us 43.2. So 32 times 1.2 is 38.4. 24 times 1.2 is 28.8. 26 times the growth factor 1.2 is 31.2, followed by 34, giving 40.8. 22 will give us a future trip of 26.4. So adding this up, so the origins for zone 1 is 93.6. Origin for zone 2 is 110.4. Trip production or trip at generation for zone 3 is 98.4. Trip destination or trip attraction for zone 1 is 98.4. Attraction for zone 2 is 115.2. And trip attraction for zone 3 is 88.2. So if we're going to add this up for the origin, it's equal to 302.4. And at the same time, we add your destination values, we also arrive at 302.2. This is how we compute for your future values using growth factor. And this table now is our growth trip table. Okay. Another example, let's say a zone composed of 275 households with car and 275 households without car. The average trip generation rates for each group is 5 and 2.5 trips per day, respectively. Assuming that in the future, all households will own a car, find the growth factor and the future trips of the zone. assume that the population and the income remains constant. So in this case, our given, or we can tabulate our given. So in the present, no cars have 275. Those owning a car is 275. So in the future, we now assume that everybody has cars already. So meaning in the future, wala ng household na walang sasakyan. So this value now is 0. And then in the future, all of them will have cars. Therefore, the total households now for the future owning a car is 550. So you're given the trip rate of those with cars at 5 and those without cars are 2.5. So given this table now, so we can now solve for the growth factor using our general equation of f sub I, or f sub I is equal to the future over the present. And since population and income are constant, we could simply cancel them. Our equation now will simply be reduced to vehicles, number of vehicles in the future divided by number of vehicles in the present. So from our table, we had 550 to 75. So we're given now the future, or the growth factor of 2. So with this, we can now compute for our current trip rate. So the current trip rate is 275 times 5 plus 275 times 2.5. So meron tayong 275 na may sasakyan times yung trip rate ng may sasakyan is 5. 275, no cars, and their trip rate is 2.5. So solving for this value, we have 262.5 trips per day. So T prime now is equal to the current trip rate times your future, or your growth factor, and this will give us now a value of 4125 trips per day. So this means that the future trip will have a different trip rate already. So intuitively thinking, trip rates now will remain in the future as the same. So it will still be 5 for those with cars and 2.5 for those who do not have cars. So therefore, the actual trip rate now for the future will be equivalent to the number of vehicles, or the number of household owning vehicles, times the trip rate of those with cars, which will give us 200 or 2,750 trips per day. So this is the actual trip rate, since the trip rate will be constant for the future. Okay. So you can, using growth factor, ito yung makuha, using the actual trip rate or the actual future, we have this value. So from example number 2, it can be concluded that the actual trips generated would be much lower than those computed trips from your growth factor method. Okay? So usually, pag gumamit tayo ng growth factor method, mas exaggerated siya compared dun sa actual na values natin. So therefore, growth factor models would normally be used to predict external trips where no other methods are available. For internal trips, regression models will be more suitable in estimating your trip distribution, or your trip generation and attraction. So let's have example number 3. Let's say a zone has a household population of 400, consisting of 200 households with no cars, 150 household owning a single car, and the remaining household owning 2 or more vehicles. So the trips generated by each household is 2 2.5, and 1.5 respectively. Assuming that the population and income is constant, determine the future trips for each situation. So if each household will own an additional one car, and B, if the population is decreased from 3,500 to 2,000 and the income is the same, and if we have the income increases from 300 to 350, the population is constant. So this will be our different conditions, for example, from number 3. Okay. So for our solution, we can tabulate it again. So the number of cars, we have no car, single ownership, 2 or more cars owned. So in the present, we have 200, 150, and 50. So in the future, we are expecting that all of the household will have an additional of one car. So meaning 200. So yung dating walang sasakyan na 200, meron na silang isang sasakyan. At yung dating 150 na isa lang sasakyan, ngayon meron ng more than 2 or more. So masama na sila dito sa 50. Okay, so that will be our future value. So for our solution, for our growth factor, since for letter A, income and population is constant, then for our growth factor, that would simply be the future value of the vehicles owned divided by the vehicles owned in the present. So in the present, those having vehicles is 200 and those owning vehicles in the future is 400. Thus, the growth factor now is equal to 2. So for our current trip rate, using growth factor method, we'll have 200 times 2 plus 150 times 2.5 plus 50 times 1.5, which will give us 850 trips per day. Using our growth factor 2, our future trip rate now will simply be the growth factor times the current rate, giving us a future trip rate of 1,700 trips per day. Computing for the actual future trip rate. So we'll now use the trip rates 2.5 and 1.5. So we'll have 0 times 2 plus 200 times 2.5, 200 times 1.5, which will give us 800 trips per day. Okay? So next, we have for B, constant is income. There is now a change in the population. So for our growth factor, that will now be 2,000 divided by 35 times 400 divided by 200, which will give us a growth factor of 1.143. So for the future rate trip, that will simply be growth rate times the current trip rate of 850, which is now equal to 971.428 trips per day. And then for letter C, constant is the population. Ang nagbago is the income. So for our growth factor, that will now be equivalent to 350 divided by 300 times 400 over 200, wherein our growth factor F is equal to 2.33. For the future trip, same process, just multiply the growth factor F to the current trip rate, which will give us now T prime of 1,983.05 trips per day. And then lastly, if both the population and income changes together with the number of vehicles owned, then we now have the growth factor as 2,000 divided by 3,500 times 350 divided by 300 times 400 over 200, wherein the growth factor now is 1.1. 333. So the future trip rate now is equal to 1.33 times 850, giving us a value of 1,133.05 trips per day. So if we're going to observe, as you can see, the future trip rate when population decreases gives us a lesser value of trip increased compared to when we have income increase. So if one of the factors increases, more or less will have a greater value in the future compared to when one of the factors decreases, it would now have a lesser increase in the future trip rates. Okay? So example 4, surveys made of the present condition for various land uses. Producing the following data, estimate the trips per unit area of land use. So we have different zones with different land uses, with their present land area and their present trips or number of trips. So for our solution, we now have, for your future, we are given that the future area for each of our zones will also change. Okay? So may lumaki yung area ng land use, may lumiit, may nadagdagan, may nabawasan. So in here, what we will do is to compute now for our trip rate. So the trip rate now will be computed. So instead of using your population, vehicle, and income, in this case, we are using the area. So for the trip rate, that will simply be the trips divided by the area, which is now 2808 divided by 780, 2432 divided by 1520, 2562 divided by 915, 2562 divided by 610, which gives us 3.6, 1.6, 2.8, and 4.2 trip rates for each zones. Giving this trip rate for our future trip, we now compute this as our growth factor, future area, divided by the present area, multiplied to our current trip rate. Okay, so that will now be equivalent to 3.6 times 810, 1.6 times 15, 2.8 times 980, and 4.2 times 11, which will give us the following value. So this is our future trip already. Okay? So parang ginawa lang natin, instead of using the growth factor, which is future over present, yung trips per area ang kinuha natin. Okay, so it's the same. Next. So next we have category analysis, which is also known as the cross-classification method. So this separates all the households into categories classified according to a set of criteria and assign a constant reproduction rate to each category. So these categories now may be one of the following. So we have the household size, the number of owned cars or vehicles, the household incomes, and others. So for category analysis, let's have an example. Say the number of cars is the main variable in determining trip making in a certain area. Based on the present number of households and trip making activities, determine the future trips. The given table shows the current condition based on interviews. So we now have categorized in terms of family size and the number of cars per household. And per category, you also have the number of household and the number of trips. So there are now two categories that we have: family size and number of cars. Okay, so with this table, we can now solve our problem. So the average trip generation rate per category may now be calculated by dividing the number of trips by the number or households for each category. So that is, so the number of trips divided by the number of households. So we have the average trip now will be 200 divided by 100, 500 divided by 2, 450 divided by 150, and then for a family size more than 3 with one car is 200 over 40. So same process for those households owning two cars. So we have 150 over 50. So we have 3, we have 3.5, we have 4, and we have 7. So after solving now for our average trips for each family size and for each number of cars owned, we now compute for your future trip generations by simply multiplying your average trip generation per category to the future number of households. So we have the number of average trips we have computed in the previous slide. The number of future households were estimated at these values. For those owning one car, we have this as those who have or will be owning two cars. So with this, just multiply. So we arrive at 2 times 200. So we have 400, 625, 300, and 250. And then for those households owning two cars, for a family size of 1, we have 450. A family size of 2, 700. A family size of 3, 400. And a family size of more than 3, owning two cars, is 170. So we have already computed your future trips. So another example, we have Magnolia had the following land use activity statistics during morning peak hour in the year X777. Estimate the total trip generation during that trip. So we have here the different unit types. Then we have the number of each units with their respective trip rates for inbound and outbound travel. So for our solution, we compute for the person trips, inbound and outbound, by simply multiplying the quantity to the trip rate. So person trip for inbound, we have 582 times 1.5, 873. So next we have 128. Next, 313, 60, 30, and 180. Then for the outbound, that will now be 250 times 0.83. It's 208. For the other values, the same. We have 17, 46, 105, 35, 24, and 75. So from these values, the trip production now will simply be equal to 1746 for this value. And the trip attraction will now be equivalent to 719. Note that the total trip attraction does not equal the total trip productions because there are trips also coming outside Magnolia. Okay? So if that's the case, so whenever the trip production and the trip production and the trip attraction are not equal, it would simply mean that there is an effect by the external zones in our study area. Okay? So question, saan nanggaling si trip attraction equal to 719? It is simply the sum of these values, 128, 313, 60, 30, and 188. So why did we not include the residential? So since within naman siya, okay, so ibig sabihin nandun na sila mismo sa area natin. So ang nag-a-attract lang would simply be the other locations. Okay? Next, we have example 3. Calculate the total number of daily trips generated by 100 households within a sample urban zone. Use the information on trip rates and the number of each household category with. So we're given here the daily trips per household together with the number of cars owned per household. Then we have the number of households within the zone is equal to 100. So using this table, we just simply multiply the trip rate for each category, the trip rate, by the number of household per number of household. So for the generated trips, that will simply be the trip rate times the number of household for each category, 0, 1, and 2 plus. That will be equal to 4.16. It's 3.4 times 9, so 30.6. So following the same procedure, 1.85 times 23 will give 42.55. 2.15 times 2 will give 4.3. Same goes, 2.02 times 2 will be 4.04. 3.10 times 14 is 43.4. 3.8 times 14 is 53.2. Ganun lang siya. Just multiply the category to the other category. Next, we have your regression analysis, which is a general form for your trip generation. That will follow that the function or the trip generation for zone I is equal to the function of x1, 2, x2, x3, x4 until x sub k. So trip models are usually linear. Therefore, we could equate this as T sub I is equal to E sub O plus A sub 1, X sub 1 plus X sub 2, X sub 2 plus EI XI plus AKXK, wherein A are the coefficient of regression equation, which is obtained from your regression analysis using the equation B equal to N. This is from your statistics. N summation of xy minus the summation of x times summation of y all over n times the summation of x squared minus the summation of x squared. And then A will simply be equal to bar y minus b times bar x. So for regression analysis, the trip rates are treated as continuous variables that can be negative, meaning it is unrealistic. Different indices or dependent variables are normally considered that may have influence on trip making. So the variables that would affect trip making would be the population. The index for the population will be daytime, residential, the number of workers, and others. For land use, that will be land area by usage, floor area. Economy, the retail sales, industrial production, the income, and others. And then social activity, car ownership, household size, number of students, and the like. So for regression analysis, let's say the following model is compiled. 4 shopping trips generated during the weekly peak hour for this activity, which is 5:30 to 6:30 p.m. on Fridays. The relationship is expressed as the trip rate for shopping is 0.15 plus 0.1x1 plus 0.01x2 minus 0.145x3, wherein T is your total number of vehicle-based shopping trips per household during the peak hour. X sub 1 is the household size. X2 is the monthly income of the household in thousands. X3 is the employment in neighborhood in hundreds. So we calculate the trip rate for a household of 4 people with an annual income of 30,000 within a neighborhood of 1,000 people employed. So for our solution, we just simply substitute our x values. So x sub 1 will be the household size, 4. X sub 2 is the income of the household, 30,000. Pero it's in thousands, so you just simply divide it by 1,000, kaya 30. And then employment is in hundreds, so 1,000 divided by 100 is now x sub 3 equal to 10. Substitute x1, x2, x3 in the equation, so we get now the total trip rate for the category for people with income 30,000 for a neighborhood of 100 employed will now be equivalent to 2.3 vehicle trips. Another example for regression analysis, the trip rate of a zone is explained by the household size from a field survey. It was found that the household size are 1, 2, 3, and 4. The trip rates of the corresponding household is shown. So we now fit a linear equation that would define the trip rate and the household size. So we now have household size. We'll use this as x value. Trips per day, or the trip rate will be our value for the variable y. So this is our data. So what we will do, we compute first for the products of your x and y's. xy. So we have 1 times 1, 2 times 2, 3 times 4, 4 times 6. Next, 1 times 2, 2 times 4, 3 times 5, 4 times 7. Then 1 times 2, 2 times 3, 3 times 3, 4 times 4. So adding them up, we have now 5, 18, 36, and 60. So from there, we now identify the number of our input. So we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next, the summation of x's is equal to 1 plus 2 times plus 3 times 4. We multiply it by 3 since we have 3 trip rates for each x. Next, bar x will now be 30 divided by 12. So the sum of x divided by n is equal to 2.5. The summation of y is now equal to 5, 9, 12, 17 is equal to 43. So bar y is 43 divided by n, which will give us 3.58. Summation of xy, we have 5, 18, 36, 68, which is equal to 127. Then we have summation of x squared will now be 1 squared, 2 squared, 3 squared, 4 squared. Again, multiply it to 3 since we have 3 trips per day for each household. So that will give us 90. So applying now the equation of B, we get 1.3. Then applying A is equal to y bar y minus b times bar x. So we get 0.30. In this case, our equation now will be y is equal to 1.3 b plus, or 1.3x plus 0.33. So this is the equation that would define or relate household size x in trips per day y. So that's for the first part, or the first submodel of forecasting or travel demand forecasting. So thank you for listening.